Hey, what's going on, everybody? Welcome back to the channel. So, today we are diving deeper into the tuna and the moon. What does the data say? So, this is part two. If this is the first tuna and the moon data episode podcast that you're listening to, go back and listen to part one. That's really important because I'm going to go over some of the nuances to the data analysis pretty quick on this one. I probably dragged on too long about it on the first one, but go back to the first one, and I have another part that's going to come out, part three. So on part two, we're going to talk about Fisherman's Landing, very popular landing down there in San Diego. Those good people, and so this is the second part. Third part is going to be H&M Landing, and what I'm doing is I'm building the data up and putting it on top of each other because the reason why I'm doing it by landing is because that's how the data is saved historically. But generally speaking, any one of those boats out of any one of those landings, you have just as good a shot at getting on tuna than the next one, save for maybe like a couple 1-2 boats that just always go out there and kill it every time. Been on those boats, no big deal. Got limits of tuna. Um, but other than that, because those boats get booked up pretty fast, quick in a hurry, your chances of going out any of these landings and landing tuna is basically the same as long as you're doing what the deckhands tell you to do. But again, we hear so much discussion and talks about the moon and how do the fish react to the moon, blah blah blah, that I like to dive into these things myself. So let's get started. So we all know about the moon. The moon causes tides, all that good stuff. You have new moons, first quarter, full moon, third quarter, and the duration of the moon cycle is always around 29 days. And that's all well and good, but this is a data analysis, not word analysis. So we need to be able to turn those words into data. And one thing I learned in the military as well is that the moon has illumination. So like when you have a first quarter moon, that is 39, 40%, whatever that means. Someone much smarter than me decided the illumination and when these phases happen. The moon is either increasing in illumination, so the next night this is going to be 45%. I don't know, I'm just making it up. It's going to be higher, and then when you go from the full moon to the new moon, that percentage starts going down. So you've tracked that percentage, is the moon getting bigger or is it getting dimmer? This is just an example data from April 4th of 2025. And so there you go. So I'm going to use this in my data analysis as one of the lines on the graph that you will see, this 39%, because you can't graph. You can, uh, what I'm trying to say is this is data analysis, not word analysis. Full moon, let's go on. Okay, so one other important thing to understand is, when you have a new moon, so that means when you can't see the moon in the sky, it's 1%. Okay, and then on the other end of the spectrum, when you have like 98%, that's a full moon. So you're always going somewhere between 1 to like 99%. I never see either 0% or 100% on these moon phases illumination. Someone smarter than me can answer that question why I don't see that, but that's just me. But anyways, as I was saying, so I learned in the military that the moon has this percent of illumination, and that was important for us when we were going out do something at night to know how dark it was going to be. Do we need to bring our NVGs or not, et cetera, et cetera. And then the other part of this data analysis, I use sportfishingreport.com. This is a pretty cool website. They have a whole bunch of different historical fish count data. I've never seen anything like this on, when I was growing up in the world, but this is pretty cool. You can see, these motivators with their nice fish and all that good stuff. So as you see here, blue Lincoln, that has something to do with their blood. They get something, some of them get something in their blood. It's like a scientific word that I'm not going to try to remember right now, but turns them blue, which is much different than the blue people of Kentucky. Go ahead and Google that one and see why some people in Kentucky turn blue. Anyways, let's move on. All right, so data limitations and assumptions. So I'm just going off of dock totals. They're very large numbers. I can't tell which trips were actually targeting what species, and I'll show you what I mean by that in a moment. But I have controlled for that in a way I'll get to in a second. I'm assuming that basically, all these boats are coming back from like a day and a half to like a 2-3 day trip, and they're specifically targeting pelagic fish that are biting. In the summer months, that usually means tuna, right? They're always going to go out and look for the tuna first, and then they'll do the paddy hopping and stuff like that second, usually. That's important because you want to know that the data you're looking at is valid, right? So if you have a whole bunch of fish in the fish count, but there are no tuna, well, maybe because there was no tuna boats coming back to dock that day. And so here's kind of where you hang your hat as in this type of analysis is the law of large numbers. It basically states that when you have a large amount of numbers, the average of the results obtained from many independent random samples converges on the true value, if that true value exists. So if I see that all this data that I'm going through on a particular day or a particular percent illumination of the moon start stacking on top of each other, then the law of large numbers says that, well, if there is something to glean from this analysis because you're using a lot of large numbers, this true value actually exists. This is pretty important because if you can crack this code on when tuna activity is, when the tuna are biting the most, then you would want to plan your trips around that, right? But you don't have to take anything I say. I'm just a guy on the internet with a YouTube channel and a keyboard and a microphone. You do you. I don't really care. This started off as a fun project, and so that's what I will continue to treat it as. But you can glean from this whatever you want. And with any type of a data analysis, you're looking for trends. You're looking for trends over a long period of time because anything can happen once. But does that thing happen at a rate that is so predictable that you can actually plan around it? Now, one thing I mentioned earlier is, I use dock total. So this is just an example. So here on June 1st, you have all these different fish in the fish count, right? You have 100 bluefin tuna, and then you have all these people. So a lot of these trips, they're not targeting bluefin, but they end up in the fish count. So I basically have tried to control for that by always just looking at the bluefin number and the angler number. Because if I always use that same yardstick, then I control for that. But if I try to start picking, if I say, oh, I'm going to make an assumption that of these 100 bluefin tuna, of these 163 anglers, only 100 of them are actually targeting that. So I just kind of made an assumption. And assumptions are dangerous because you don't want to make too many of them, or else you'll start injecting your own dynamic into this crazy thing. So I just said, you know what? I'm just going to take the number of bluefin tuna, the number of anglers. I know that there's a lot of trips not targeting bluefin tuna, but those numbers are going to be wrapped up. But if I do that every single time and then find a trend, then that might be something to take a look at. So again, you got to go back and look at part 1, but the graph ends up looking like this. So this is Seaforth Landing. Like I said at the start, we were talking about Fisherman's Landing. So here is I'm just kind of doing this to warm you up on the new graph in this part 2. Here's the moon. The moon is this orange line. See, it always goes somewhere between 1% and 100%, represented on this graph as 1 or 0, essentially, right? And then on the same graph, I have this blue number, BFT per angler. So pretty simple. You take the number of bluefin tuna caught divided by the number of anglers on that fish count, and you get this crazy looking graph. So again, it can be really hard to make much of a graph like this until you got to start looking at the spikes. Where do you see these outliers? So yeah, I know this spike is not as tall as these other ones, but look at what was going on in June. Not much. So to me, this is still an outlier because all of a sudden you have this spike in activity after a relatively low or slow period of time. So, and again, this analysis is June 1st to August 31st of 2024. So day one would be like June 1st, and then day 91 would be August 31st. The dates aren't all that important. Remember, we're doing an analysis over the moon cycle, not the dates on a calendar, because I want to know just because the fish bit really good on July 1st last year doesn't mean they're going to bite really good on July 1st this year if it's a different moon phase, right? That's what we're trying to figure out. We're trying to make some sort of I'm trying to make something out of this madness. So I'm going to move on to the next slide. And the next slide is the new data that you haven't seen yet, that you came here to see, and that is the fisherman landing count. So immediately you see something. You see this lull again in July, right? So those middle days, that's July. But you do see a lot of spikes. Now, the number of boats that Fisherman's Landing has and Seaforth has, and then my other analysis going to H&M, the number of boats change, but again, I kind of account for that by always just comparing the number of bluefin caught to the number of anglers. So you have this spike here before the new moon on day 7 of this analysis, and then you get this spike here. So I think anything 1.5 or greater is pretty good, for sure. So I start that. Then you have this dip. Now you can dive into this more. Maybe there just weren't any boats going out on the 19th day of this analysis, and maybe I'll do that. I could look at only the weekends, right? And so then that kind of cuts out of some of those slower days where boats aren't going out anyways. But more or less, the boats are always getting off the dock this time of year. So maybe that makes a difference. Maybe it doesn't. Then what do you see? So then you see this big spike after the full moon, and then you see a downgrade in activity. And then I like this spike here just to get another data point because it's somewhere before the full moon, and you kind of don't see much. Then you see something, then it goes down, and then I'm sorry, did I say full moon a second ago? I meant new moon. This is the new moon, and then after the new moon, bam, you get another spike in activity, and then you get this down time here in July, and then bam, you get another spike here. I like this spike. I'm going to talk about this spike, kind of like the spike I talked about from the graph before. Remember, there wasn't a whole lot of activity. Then all of a sudden, there's a lot of activity. That's interesting. We're seeing it again in a different landings count. So I'm growing confident that the landing count I was looking at before wasn't just a fluke. Like Fisherman's Landing was also able to do it. And then you get these big spikes again. These are up over 2, which is pretty cool. I mean, if you're going out and getting 2 BFTs on offshore, that's good. Remember, your limit is 2 a day. So these people are getting more than their limit. How do they do that? Boat limits. And also some of these boats are multi-day trips. So you can come back with 6 tuna, for example, if you're on a 3-day trip. I don't know much, but I think 2 times 3 equals 6. You guys can check me on that. And then this is interesting just because it's just as high. And then also it's here again, we have like this spike that seems to coincide with the new moon, it's not exactly on the new moon. It's like if the new moon is on day 66, this spike is on day 67, and then you get another one a couple 3 days later. And then I think this spike is interesting. This is right before the full moon. So if you can see, the full moon is day 81. This spike is just a little bit before that, and you can kind of see how the graph will kind of, what's it do here? It kind of angles out a little bit, this line. And then you get this big spike towards the end of these dates. And that, remember, that's essentially the new moon is coming. So that's really interesting. Lots of spikes. It can be hard to really determine things just from this. So then, let's take a look at the spikes only. So if you look, all those stars coincide with one of these dates. Then because I can look at the moon illumination on those dates, I put that here. And then the description of the moon cycle. So 33%, that's 5 days before the new moon. 62%, that's 6 days before the full moon. Blah 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 blah. And you go down the table here. So next slide. Listen, as always, the best time to go fishing is when you can go. But I think there does start to be something you can glean from some of these numbers. And I don't know why my slideshow is not proceeding. Okay, a little technical difficulties, but we're back. So now let's take those spikes and start putting them on our timelines here. So as you can see, we have the new moon up here, and this is the number of days before the new moon, then days after the new moon, days before the full moon. Look how pretty my full moon picture is, and then days after the full. So of those numbers that you just saw, now let's put things on the graph. So on day 8, after the full moon, we had an uptick. On day 5, before the new moon, we had an uptick. So let's just build this out. So, and yeah, I think that's it. So those are all all those rows on that table you just saw. Those coincide with my handy dandy little bluefin tuna icons. So that's pretty cool. But I also did an analysis that I want to add to right? And so let's look at fisherman's plus Seaforth Landing. So again, I did Seaforth Landing in part 1, and this is part 2 using fisherman landing. So I'm just transposing what I found on my Seaforth Landing analysis to my fisherman's landing analysis and adding those tuna in. And let's build this out. I didn't realize I had that much animation, but hey, this is starting to get a little bit interesting. 8 days after the full moon, something about it, and you can make an assumption that that 8 day, because the boats submit their fish counts when they return, that okay, then if you believe that, then target the 6th day after the full moon or the 7th day, because the numbers actually lag a little bit. But in order just to kind of remove me from trying to make that assumption as well, what's really important is the percent moon illumination, not so much the date of the fish count. So you're gonna have to try to figure that out a little bit. Basically, what I'm trying to say is, if this is off, it's only off by a day or two. And if you're going for a 2-3 day trip, then you should be covered. But so it's interesting. So on the new moon, you kind of get this scatter, kind of interesting. And then on the full moon, you get this uptick somewhere between 4 to 6 days, and then you get an uptick, pretty quickly after the full moon. So, and then you get like this really big uptick like that week after the full moon. And again, you can adjust a couple days either way if you want, based on your knowledge of how the fish counts are published. So you do you. But I think this is interesting. I think there's something to start to be gleaned from these numbers, especially around the full moon, and the activity before and the activity after. You hear captains always talk about, they don't bite on the full moon, it's before and after, and that's great. Um, but again, this is just a straight analysis on the data, and always listen to your local charter captain. Anyways, all right, so what did we learn today? The first thing we learned is the best time to go fishing is when you can go. But other than that, either side of the full moon seems to be best, somewhere between like 70 to 80% illumination, and then 40 to 50% illumination. In days, that typically means 3 to 4 days uh, before the full moon. And this, I think I need to redo my numbers, but I just said it was like really 5 to 6, something like that. Um, and then that 8 day after the full moon seems to have a lot of activity for some reason. Is that because the landings just happen to always be fishing on that 8th day after the full moon? I don't know. You tell me. But according to this analysis, it seems to be something about that time in the moon cycle with that illumination that the fish are getting nice and hungry. And so remember, kill something, drag it back to the cave, and eat it. See ya.